Hi and welcome. I hope everyone is okay. Now, in this lesson, we will learn variance and standard deviation. Okay, now we can start the interquartile. As you remember, range is based around the median. In here now, we will investigate a possible way to define variation based on the mean. Let's choose some sets of 5 numbers with a mean of 10. If you notice that we have 3 sets and for all sets mean is 10. For example, for one mean is 1 at plus 2 3 6 10 50. 50 over 5 means 10, and the other set the mean is 8 plus 9 17 plus 10 27 plus 11 38 plus 12 50. 50 over 5 means 10. And for the third one, 1 plus 10 11, 11 plus 12 20, 23, 23 plus 13 36, 36 plus 14 50. 50 over 5 mean is 10, and it's also all sets mean is 10. The deviation of number tell us how far and to which side of the mean it is. Numbers greater than the mean have a positive deviation, whereas numbers less than the mean have negative deviation, as indicated in the following diagram. And if your data the right side of the mean and your deviation is positive, and if your data the side of the left side of the mean, your deviation is negative. Let's find the deviation of each set of our 5 numbers and then calculate the mean deviation. Okay, now please remember that all sets mean is 10, so mean 10, and our deviations 1 minus 10 becomes negative 9. 1 minus 2 minus 10 becomes negative 8, and 3 minus 10 becomes negative 7, and 4 minus 10 becomes negative 6, and 40 minus 10 becomes 30, excuse me, 30. And for the second set is the mean 10. So I want to compute the deviation for all data. 8 minus 10 and 9 minus 10 and 10 minus 10, 11 minus 10 and 12 minus 10. So it becomes negative 2, negative 1, 0, 1 and 2. For the last set, as you remember, mean 10, and I want to compute the deviation for all data, and 1 minus 10, 10 minus 10, 12 minus 10, 13 minus 10, and 14 minus 10. So our deviations are negative 9, 0, 2, 3, and 4. And please notice that if you want to the mean deviation, and you should also plus the all deviation, and you can notice that differently. For example, if you sum to compute the sum of all deviation, and if you want to compute mean deviation, when you the sum of the deviation, you can compute 0 for all sets. For example, -9 plus -8, -17, -17 plus 7, -24, -24 plus -6, -30, -30 plus +30, it becomes 0. And the other set for 2, -2 plus -1, -3, plus +1 plus +2 becomes 0, and -9 plus 0, -9, and plus +2 plus +3 plus +4 becomes 0. So that's very interesting, that for all deviation, the sum of the all deviation becomes 0, and we don't compute the mean. We don't compute the mean deviation, because all sets deviation, the sum of the all sets deviation become 0. We can excuse me, we can notice that the mean deviation is not useful way of measuring the variation of a data set, because the positive and negative deviations cancel each other out. So if we want to measure of variation around the mean, we need to ensure that each deviation is positive or 0. Okay, now how we can improve these situation, and how we can compute the mean deviation for become positive or 0. We can do this by calculating the mean distance of the data values from the mean, which we call the mean absolute deviation from the mean. For example, the sum of absolute the distance all data and mean over the sum of the data over the numbers of the data, for it's called n. But it's hard to calculate the accurately and efficiently for large sets of the data, and it's difficult to work with algebraically. So approach is not used practice. If we want to if you want to compute the mean deviation, and if we use the absolute mean distance of the data values, but this formula this formula not useful is not useful for large data, and very difficult work with algebraically. So we should improve the alternatively formula, and this formula, the square deviation, and it means all data distance the mean square. Okay, for all data values and find their mean, this is the mean square deviation from the mean, which called the variance of data. Now if we want to compute the or work out the variance, we should use this formula instead of the absolute related to absolute formula, because this formula is not useful for large data and difficult. But now our formula for variance is the square deviation. Okay, and for measurements and deviations in meters, say the variance is in a meter square. So to get a measure of variation that is also in meters, we take the square root of variance. Square root of variance means standard deviation. Because when we square the all distance and all data and mean, we should find a meter square, but standard deviation is should be a meter, for example. We should compute the square root of variance for finding the standard deviation. So now we have two formula. The one of them for the variance, and the second one standard deviation. Standard deviation is also the square root of variance. Okay, now this looks no easier to calculate than the mean absolute deviation from the mean, but maybe we can arrange this formula. Okay, now we will work on the variance formula, the differently. Maybe we can use we can use different formula about variance, about the mean squared deviation from the mean. Okay, now please remember that our variance is the sum of x minus mean square over n. And please imagine that we have only two data, x1 and x2. For example, our mean is x1 and x2 over 2. Okay, now and the variance is the sum of x minus mean over mean square over n. And it means our x is x1, so x1 minus mean x1 plus x2 over 2 square, and plus x2 minus mean x1 plus x2 over 2 square, and we have two data over 2. Okay, now this it means x1 minus x2 over 2 2 square plus x2 minus x1 over 2 square over 2. And it's also this process the same, because positive square and negative square becomes positive, and this process is the same, and I can write 2 multiply x1 minus x2 over 2 square. Okay, over 2 this, and it means x1 minus x2 over 2 square means x1 square plus x2 square minus 2x multiply x1 multiply x2 over 2. Okay, and now I can this situation that means x1 square plus x2 square over 2 minus x1 multiply x2. And please notice that this situation is all the mean is all square. That's it becomes 2 square 4, and this is 4 and over 2. Okay, now this means I want to draw a rectangle. x1 x1 square plus x2 square over 4 means the sum of x the sum of x over n square. X plus x1 multiply x2 over 3 if 2 becomes the x minus x mean the sum of the over square over 2. So it means this formula is the variance can be written the sum of the x square over n minus mean square. So if you use this formula, it's very easier than this formula. So for the variance, for computing the variance, we should use this formula instead of this formula. Okay, now if I want to summary, if we want to compute the variance, we should use the sum of all data square over n minus the mean square. Okay, minus the mean square, and it's also mean the sum of all x all data over n. And if you want to compute the standard deviation, you should compute the square root of variance, and it's also the square root of the sum of x square over n minus mean square. If you have group data, in group data, your data has frequency, so you should all numbers multiply frequency, and you should over the sum of the frequency. Okay, now if you want to compute the variance for group data, so for the group data, your variance formula is the sum of the all data square multiply frequency over the sum of the frequency minus mean square, and mean is the sum of x over n. Okay, now I think if we work on an example, you can understand easily for computing the standard variance and standard deviation. Okay, now please notice that this example, for the set of 5 numbers 3, 9, 15, 24 and 29, find the standard deviation. Which of the 5 numbers are more than more than one standard deviation from the mean. Okay, now we should compute the mean firstly. Mean, you know, the sum of all x over n, and it means 3 plus 9 plus 15 plus 24 plus 29 over 5, and it means 12 and 27 and 51 and 80 over 5 means 60. And our variance formula, you know, the sum of the all x square over n minus mean square. Please notice that our variance formula is the sum of all data square, the sum of the data square over n minus mean square. Okay, now our variance is 3 square 9 plus 9 square 81 plus 15 square 225 plus and 24 square 576 plus and 29 square. I want to compute the 29 square. Excuse me, I computed the root of square. I want to change 29 square means 80 is 141. 141 over the number of data 5 minus mean square or 16 square, and 16 square means 256. And I want to compute this process by using my calculator, and 841 plus 576 plus 225 plus 19, because 81 plus 9 90. Okay, and over 5 and minus 256 becomes 19.4. And if we want to standard deviation, and it's also called SD, means the square root of this variance. It means the square root of the 19.4, and I want to use my calculator, and the square root of the 90.4, it means approximately 9.5. Okay, and standard deviation 9.5, we found these section, and the other question, like which of the 5 numbers are more than one standard deviation from the mean? Okay, our mean is 16. Our mean is 16. 16 is here. And one standard deviation plus standard deviation, and back to mean, one standard deviation minus standard deviation, and 16 minus 9.5 means 6.5, and 16 plus standard deviation 25.5. Okay, what are they? Our data. Okay, this data here, and I want to copy paste. Now it's here, and and uh, our three data. Uh, they ask me five no more than uh, our data is three more than one standard deviation from the mean, because one standard deviation back it's called 6.5, but our three less than uh, back to one standard deviation of mean. And our data is 29 uh, more than 25.5. So these data more than one standard deviation distance from the mean. Okay, and our answers are 3 and 29. Okay, now we have one more example, and I hope you can understand easily, strongly when we solved these questions. And find the standard deviation of the values of x given in the following table. Correct the three significant figures. And please notice that we have group data. We have grouped data, and so we should compute the x multiply frequency, x multiply frequency, and we should compute the sum of frequency. Okay, now 12 multiply 13, 156, and then 14 multiply 28, 392. I want to check. Yes, 392. And 60 multiply 10, it means 160. And the sum of the x multiply frequency means 8 and 0, 8 and 0, carry to 2, 3, 6 and 7. And the sum of the frequency that 13 plus 28, 41, and 41 plus 10, 51. And if you want to mean, our mean, the sum of x plus x multiply frequency over the sum of frequency. Okay, and it means 780 over 51. Okay, now I want to calculate my using my calculator, and 780 over 51, it becomes 13 and 13 and 88. 13 and 88. But in this question we should use not approximately result. We should use these number. Okay, and we should please remember that the variance formula the variance formula means the sum of x square multiply frequency over the sum of frequency minus mean square, and it means uh, 12 square 12 square multiply frequency plus 14 square 196 multiply frequency and 16 square 256 multiply frequency over the sum of frequency, it's also 51 minus mean square, and we should use mean, not approximately value, exactly we should use exactly value. So this exactly value is 780 over 50, but please don't forget the mean square. So 780 over 51 square. Okay, now our variance is becomes, I want to look at the result because I want to use our time very effectively. It becomes okay. Now the variance of this, it means 9,920 over 51 minus 780 over 51 square, and I want to use calculator. 9,920 over 51, it becomes like 194.5 minus 780 over 51 and square, it means 192.7, and the result of the this process, 194.5 minus 192.7, and it becomes 1.8, and our variance is approximately 1.8. Please remember that standard deviation is the root of variance, and the square root of 1.8. The square root of 1.8 means like 1.34, approximately 1.34. Okay, now and we could compute the standard deviation, but please notice that these notes. The first one, the rounded mean causes a substantial error, so we calculating the variance or standard deviation always use these formulas rather than rounded value for the mean. So in the standard deviation, for compute standard deviation, we shouldn't use rounded value. Also, please remember that I didn't use rounded value of mean I used the mean value exactly. Okay, and now the other one, when data are grouped, actual values cannot be seen, but we can calculate estimates of the variance and standard deviation. To do these, x should now represent class mid values in the variance formula, and we should use class mid values, but we will talk about these situation another the next lesson. And for this lesson we have no time, and I want to one more example for you solve for today, and a few minutes later I will send a example about this lesson, and I want to solve this example by yourself in the last 10 minutes in this lesson, and I want you to send me your solution. For now, our lesson finished, and have a good lesson and have a good days.